Okay, number 7, we are back to this interesting section. Electrostatics. 3 charged particles, let's go for it. 3 charged particles A, B, C have these, blah, blah, blah. Sketch the diagram. So I know what they want me. This is principle of superposition, and I'm going to sketch the diagram. Let's go. My diagram, I have 3 charged particles A, B, C. Okay, so it's going to be 3. Are they in a right? Either it's a triangle or whatever. Let's see. Having are placed close together. Okay. Particle A is at the origin, so we can put some particle A here. Here's my particle A. Okay, I'll put my particle A. This is my particle A. Now, particle B is 4 in the X, 0 in the Y. So they are trying to cheat to see if you can do it. 0, 0. Remember that it's X, comma Y. So on the Y, it's still 0. So it's just moving in the X, 4. So this is where particle B is. Okay. It's at 4.00 meters, comma 0. That's where it is. You've moved 4 in the X. And then C, it's at 0, 3. So it goes straight up 3. Okay, because it's 3 in the Y, which is positive 3 in the Y. So it's going to be 0 in the X, then comma 3.00 in the Y. This is where it is. So that means if I'm to put the distance between A and B is going to be 4.00, because I need to sketch the diagram. I can remove these coordinates, but this is going to be 3.00 meters. Here it's 4.00 meters, and here is my particle C, and then I can show between A and B that is going to be, this I can tell you right now is going to be a 3, 4, 5 triangle. Okay, but I can say BC is equal to the square root, since it's the hypotenuse, the angle opposite the right angle. So it's going to be square root of 3.00 squared, 3.00 squared plus 4.00 squared. Okay, you can put the meters, you can put your meters, and you get BC as 5.00 meters. Okay, you can put it in the calculator, you see. So here is going to be 5.00 meters. And I've sketched the diagram, I'm done. Then here they are indicating their charges and the forces, indicating the coordinates. Oh, we need the coordinates, their charges, and the forces acting on C. So the coordinates, they wanted the coordinates. I don't know if they wanted the diagrams. Oh, they only wanted the coordinates. So I've rushed. Part A, they don't want the distances. They want the coordinates. So I'm going to remove the distances. I'm going to remove them. They want the coordinates. So this is 0.0. Then this is 0.4. Okay, 0, 4.00. And then here is going to be 0, 3.00. Okay, that's where my point C is. Okay, that's where that point C is. Now, what is the one? They want the coordinates, they want their charges. So what is the charge on A? QA is 3 points. So I can say QA is equal to 3.0. It's equal to 3.0 times 10 to the negative 4 coulombs. Then here I can say QB. Okay, this is my particle B. So I can say this QB is equal to, what is it equal to? Negative. Okay, so they want me to put their charges, so I don't have to put the value. I'm sorry for that. Here I can see that A is positive, 3.0. So for A, I'm going to put a positive. Then for B, I'm going to put a negative, because B is negatively charged. Look at him. His value is negative, negative 6. And C is 1.00, which makes C positive. So they also want their charges. I've put them. Plus, plus, minus. There we go. And they are the forces acting on C. So my particle of interest is going to be C. Now there I'm going to put, so I'm going to have to put the coordinates like 0 point, somewhere safe here, like 0, 3.00. Okay, now the force is acting on C. Since A is positively charged, is going to be pushing C away. So this is going to be force on C by A. Okay, then I'm going to have now B is negatively charged, so it is pulling C towards itself. So here is going to be the force. I put an arrow and I'm going to say this is force on C by B. Okay, FCB. There we go. So here we've shown the forces and we are done. Is there anything else? No, that's good. That we have sketched our diagram, we've showed the coordinates, and we've shown the forces. There we go, and we have done everything. So this is enough. Okay.